Section 4.3, number 9. So this is the velocity of an object moving. So it's got positive area under it, so it's going forward, has a velocity of 0, so it stops. Then is slowly slowing down, stops. Then it goes faster backwards, and then it starts slowing down till it stops going backwards, and then it goes forward. So this is how far backwards it goes, that area, how far forward, and how far forward. So this is a half by 1. So half times 1 is a half, and this is half of that, so this is 1/4. And this is in feet times seconds, so this is 1/4 of a foot. This is 1 by 2 in half, so this area is -1 foot. This is 2 by 2, which is 4 in half, is 2 minus 2 feet. So it went forward a foot, a quarter foot, back a foot, back by 2 feet, and then forward. See, this is a quarter, and that's half of a quarter, which is forward 1/8 of a foot. Write an expression involving definite integrals whose value is the total change in position from 0 to 4. Well, that would be, without doing much thinking, is 0 to 4 of whatever the equation of the velocity is, dt. However, this is a piecewise defined function, so if we want to actually get a little bit more specific, we would have to say it's this line from 0 to 1.5, 0 to 1.5. This is a line with a slope of down 2 for 1, so it's minus 2t plus y-intercept of 1 dt. This added up would get this area and this area, plus the integral from 1.5 to 4 on this line, which has a up for 1, so it's 1t plus the y-intercept. It's going 1 for 1, so this would be down a half, so that's minus 3, down a half, minus 3.5, minus 3.5 dt. So there's a better expression for the total change in position. Use the provided graph and velocity to determine the value of the total change in position. Well, it went minus 3 plus a quarter, so that's minus 2 3/4, plus an eighth, so it's minus 2 5/8 feet. Write an expression involving definite integrals whose value is the total distance traveled. All right, so now we have to make this part positive. So you could write from 0 to 4 of the absolute value of the velocity, dt. But if we're going to get specific about this, when there's absolute value, that's going to take and flip this up to where it goes up. Let's see, 1, 2, 3, 4. It would go this way and then this way. So now we'd have a section that depends on this line, a section that depends on this line, a section depends on this line, and a section depends on this line. we'd have to have 4 intervals. The first one would be from 0 to 0.5 of minus 2t plus 1, the equation of this line, minus 2t plus 1. And if we evaluated that, it should come out to be 1/4. Then we'd have to do for this line, which just is a reflection over that axis, which is just the negative of this. So it'd be plus from 0.5 to 1.5 of the negative of this, which would be 2t minus 1 dt. And that should turn out to be plus 1, because that's the area here was minus 1, but if we take the negative of it, it becomes plus 1. Plus the area from 1.5 to 3.5, 1.5 to 3.5 of not this one, which is this, but the negative of it, so it'd be negative t plus 3.5 dt. That's the equation of this line. It's -1 slope. It hits at 3.5. And that should come out to be plus 2 if we worked it out. And then finally, plus the integral from 3.5 to 4 of this, which is that line, t minus 3.5 dt. So that would be a really good expression for this, or for the distance travel, which means make all the distances, all the changes positive. Is the object's exact average velocity on 0 to 4? Well, the velocity is the average of the displacement, not the distance. So the displacement was -2 5/8. We'd have to divide it feet, and we'd have to divide that by the change in time, which was 4 seconds. So we get whatever -2 5/8 is. That's -1/2 minus 5/32 feet per second. Let's see, if I made this 30 seconds, this would be 16 30 seconds, 21 30 seconds, minus 21 30 seconds feet per second. Find an algebraic formula for the object's position function from 0 to 1.5 that satisfies s sub 0 equals 0. From 0 to 1.5, that's this one figured out at what's its antiderivative. What's the antiderivative of this line? So we're trying to find the antiderivative of minus 2t plus 1. That's the velocity. The velocity is s prime. So we have to find the antiderivative of this, which would be minus t squared plus t, and it's supposed to be 0 when the time is 0. And if I put 0 in here, I do get 0, so that's the answer.